Hi, fifth graders. Today we're going to refresh our memory on comparing fractions. And there's quite a few ways we can do this. So the first way we're going to try this out is by looking at the denominator. And a big idea is that we're going to be able to make some conclusions or some decisions about the size of fractions using fraction tiles. So I'm going to list a set of fraction tiles on the side of my page here. You can see I start with the whole number 1. And I move all the way down to the piece 1/12 at the bottom. So based on this row of fraction tiles, I can consider a couple different situations. First, if the numerator stays the same, but the denominator decreases, what happens to the size of the fraction? So I know my numerator has stayed the same because it's 1 in each one of these fraction tiles. But in this situation, I'm looking at this set with the denominator decreasing. That means the denominator is getting smaller. So in order for the denominator to get smaller, I need to be moving from the bottom of this row up to the top because I'm moving from 12 to 10 to 8 to 6 to 5. So as my denominator decreases and I move up this row of fraction tiles, I notice a pattern. And that is that the size of the fraction gets bigger. And this makes sense because remember, the denominator tells us how many pieces it takes to make up one whole. So when you have a larger denominator, it means you are split into more pieces. And if you're splitting that whole into more pieces, that means each of those individual pieces or each individual slice must be a smaller size. So the smaller the denominator, the bigger the slice or the bigger the piece. So as the denominator decreases, the size of the fraction gets bigger. I could also look at another situation. I could also say, what if the numerator still stays the same, but now the denominator increases? So this time I'm moving down my row of fraction tiles because I want that denominator, the number on the bottom, which tells us how many pieces make up one whole. I want that number to increase or get bigger. When this happens, the size of the fraction gets smaller because when we have a small denominator, we're split into fewer pieces. So the greater the denominator, the smaller the piece because we have more of those pieces. So the size of the fraction gets smaller as the denominator increases. So we can use this idea to help us as we're comparing some other fractions. So let's take a look at what happens when we have fractions with the same denominator. So remember, having the same denominator means that all of our pieces are the exact same size because the denominator tells us how many pieces it takes to make up one whole. So I'll put those fraction tiles out again to help me. And since the denominator tells us how many pieces make up one whole, that means the greater numerator must be the greater fraction. Since we have the same size parts, we need more pieces or a greater numerator in order to be bigger. And we can see this with fraction circles. So in 3/6 and 5/6, I have the exact same size pieces. Both of these circles are split into 6 equal size pieces. And I need to look at the numerator, the 3 and the 5, to see which one is greater. Since 5 is greater than 3, that means the fraction 5/6 is greater than 3/6. I can also see this using tiles or a number line. In this example, I have 2/8 shaded in green and 7/8 shaded in this yellow or gold color. So I can tell that there's clearly more pieces in the yellow or gold bar than there is in the green bar. So that tells me that 7/8 is greater than 2/8, which makes sense because 7 is greater than 2. Now let's take a look at what happens when instead of having the same denominator, we have the same numerator. Having the same numerator means we have the same number of pieces. So now the size of the pieces might be different, but we know that the greater the denominator, the smaller the piece. So that can help us figure out that what that means is the smaller denominator is the bigger fraction. So since the numerator is the same, that means we have the same number of pieces. In order to be bigger, we want the bigger slices. So for example, if I have 1/4 and 1/2, I still only have one piece because my numerator is 1, but in the left, that one piece is 1 out of 4 slices, and on the right, it's 1 out of 2. Since my whole square is split into 4 slices here, each of those slices is smaller than my square that's split into 2 pieces. That's why 1 out of 2 is greater than 1 out of 4. I could also look at this with circles. So I have 5/8 and 5/6. My numerator, again, is exactly the same. I still have 5 pieces, but I know that I'm going to be greater in 5/6 because I have a smaller denominator, and the smaller the denominator, the bigger the piece. Okay, so now we know how to compare when we have the same denominator and the same numerator, but what happens if they're different? When the numerator and the denominator are different, there are 3 strategies we could try. The first is to compare your fractions to 1/2. So for example, if I wanted to compare 5/8 and 1/3, I know that 5/8 is greater than 1/2 because 4/8 is exactly 1/2. And I know that 1/3 is less than 1/2 because I can use that rule with the same numerators to tell me that 1/3 is less than 1/2. Since 5/8 is greater than 1/2 and 1/3 is less than 1/2, that means 5/8 must be greater than 1/3 because I can compare it to that benchmark fraction of 1/2. I could also use the butterfly method strategy, and this is basically a way of creating equivalent fractions without doing all the equivalent fractions work. But that's the math that's going on behind it. So for example, let's say I wanted to compare 4/9 and 2/7. In the butterfly method, I'm going to cross multiply. So 9 times 2 is going to give me 18. I'll multiply the numerator of one fraction with the denominator of the other. Then I have to multiply on the other diagonal. So 4 times 7 is 28. Now I need to compare those two products. Since 28 is greater than 18, that tells me that 4/9 is greater than 2/7. Finally, the strategy we will use most often this year is to make equivalent fractions. So for example, if I wanted to compare 3/4 to 5/6, I need to make equivalent fractions, which means I need to find fractions with a common denominator. So I could tell by looking at 4 and 6 that a common denominator between those two numbers will be 12. So I know that 3/4 is an equivalent fraction of 9/12. And 5/6 has an equivalent fraction of 10/12. So now, since I have the same denominator, I can compare my numerators of 9 and 10. Since 10 is greater than 9, that means that 3/4 is less than 5/6. So that's a refresher of some different ways to compare fractions. We will do lots of this over the course of the year, but thank you for watching, and I hope that this helped refresh your memory.